Hey Ryan, is your radar available via API? Like, can I pull your radar feed into an app
Yes.
for Grand Sky?
We'd have to talk about it. But yes.
But technically speaking, you can.
Yes.
Like a very hesitant yes guy. You will
Is that
not
a
ask a
question
fourth
or a
question.
statement?
Just don't forget you ever asked.
Write that from the record.
Is that yeah, sure, yes, sir?
Yeah, sure.
Yeah, no.
Oh, so guys, I figured out who the anonymous coin was from. I got pranked by Bill.
It wasn't really that much of
And
a,
the prank was my door was locked. And I know there's only one other person with the key. He doesn't have a Sky Deal coin. Remember the one we found on the floor at the back wall?
Yeah.
He was able to kick it, this foot, under the door that far.
Wow.
You seem amazed by someone being able to kick it.
I mean, that's like a,
He
that's
just
gotta be like a
learned mine
cricket
by
move,
hand.
Yeah,
professional cricket move.
yeah.
He's been practicing.
There's no way you could do that.
I practiced on my office a few dozen times.
See, I like that. I like that radar.
Well, okay. All right, should we start the doohickey?
Yeah.
Great. So we're gonna talk about beyond visual line of sight flight today. I got some of the products that we've got, and a lot of what I was gonna talk about was the difficulties in getting beyond visual line of sight authorizations. So, Johnny, what's the difficulty in being able to apply beyond visual line of sight?
Many difficulties. I would say interacting with just the general airspace.
Okay.
Which could be, I mean, if you're low enough, I guess that could be anything. It could be traffic, that could be planes, it could be birds.
Okay, do you know how you get authorization to fly beyond visual line of sight?
You have to submit a request to the FAA for a waiver,
So,
which could be different amounts of, if I'm not mistaken, different amounts of approval, depending on what they say.
have you ever applied for a waiver, Bill? Have you ever applied for a waiver?
Long time.
Okay, so it's kind of a difficult process, right? From what everybody understands is the biggest barrier to getting beyond visual line of sight is the FAA. But the FAA there's a method kind of behind their madness. People ask why the FAA is so difficult to work with on getting beyond visual line of sight. And that's kind of what I wanted to go into today. So this is on the FAA's website, air traffic by the numbers. So the FAA is handling 16.5 million flights per year in the US airspace, 45,000 average daily flights. And this is all manned air traffic. None of this is drone traffic. 10 million scheduled passenger flights yearly. During peak operational times, they're going to have 5,500 airplanes in the air at the same time. 24.1 million square miles of oceanic airspace, which I don't really care about that much. This is interesting, 5.3 million square miles of United States domestic airspace. That's being controlled by 520 air traffic control towers. So you've got a very limited supply of air traffic control. They're controlling, so 520 air traffic control towers are handling basically 20,000 airports. And there are also 21 air route traffic control centers. Those are what's handling the commercial air traffic, like standard passenger airplanes, once they get into Class A airspace.
Can you share your screen on the presentation?
Yeah.
In the video you are?
No, that's our self video.
Oh, okay, no problem.
It's being recorded right here. I'm sharing my screen.
Okay, I have a question. Is it all manual, like every single request, not just BVLOS, would go through a manual approval?
Not necessarily. So, but there are 167,000, more than 167,000 general aviation aircraft. So these are the Cessna one. These are single engine, twin engine business jets. 10,000 rotorcraft and 35,000 experimental and light aircraft. So these are also in the mix. 25.5 million general aviation flight hours per year. So if you divide that out by 365 days, you want an average of how many hours of daily flights there are. There's a lot. This is Don't really care about that. 10 million, 11 million jobs generated from aviation. There are 147 terminal radar approach control facilities. And some of the dollar numbers. So the FAA has been built over the last 150 years as a reactionary organization that reacts to hazards that they've found. So things that are, they'll make, they traditionally have made regulations once something happens. So they react to it that.
Tombstone.
Yes. The common saying is that the FARs, the Federal Aviation Regulations, are written in blood because they are, and traditionally they have been. When you start adding to the number of aircraft, when you look at UAS and you start to realize that there are 3 to 4 times as many drones as there are airplanes in the sky at once, this is why it's difficult to get a waiver from the FAA, because you're asking them to fly an airplane further away than you can see it in a very large, very densely populated area with very little external control of that airspace. And I say external control because the pilots of traditional aircraft are part of the control system when they're flying and communicating with other pilots. So at most of the airports that are around Grand Forks. So this is Grand Forks International Airport. This is out of the base. So this is Grand Forks Air Force Base. And both of these have control towers that have hours of operations, which is why they've got the dashed blue line around them. Most of them are going to be uncontrolled airports, or mainly you could think of them as uncontrolled airports. So Warren, Crookston, Beaver Falls. These are airports that are in somewhat controlled airspace. This is controlled airspace to 700 feet above the ground. This one is controlled airspace down to the ground within the dash Magenta line. So you have, when pilots are operating in these airspaces, what they're doing is they are communicating with each other. So right around Crookston, right, as I'm looking at this, probably about 30 seconds ago, we've got 2 airplanes that are in the pattern at Crookston. So both of these airplanes are using Crookston Airport. The way that they are staying separated is they are talking to each other and to any other airplanes that may be using that airspace.
Within what, within that radius that you showed? So what do they consider their airspace?
So this is the traffic. This is a traffic pattern. The size of the traffic pattern depends on the size of your size, performance, speed of your aircraft, and the meteorological conditions. You look over at Grand Forks, you can see there's a reason that there's a control tower. So Grand Forks is one of the busiest airspaces in the United States. It is the busiest for having single engine general aviation type airplane traffic. And it is commonly one of the top 10 busiest airports in the United States. In addition to Grand Forks International, right here, where UND does all of the training flights, we have Grand Sky located at Grand Forks Air Force Base. This is a restricted area. It's the most permanent temporary flight restricted area in the face of the planet. It's been there since 2011, I think. So temporary is no longer a thing. As a matter of fact, this one's even on the charts. But right now, we've got an aircraft that's flying out there. That is an MQ-9 Predator that's training flight from General Atomics facilities that are at Grand Sky. There is a small UAS airport that's been designed that's right about here. Well, it's almost exactly there. So this is a place where you can expect drone activity for smaller drones. And this is the airspace picture that we're going to present to the FAA. See if we can fly drones further than we can see them. The FAA is not really into you flying an airplane further than you can see it, because you no longer have a direct mode of visibility outside of that airplane. Even with the MQ-9s and the the RQ-4s, the Global Hawks, any visibility you do have out of even very large drones is very similar for the pilot to looking through a soda straw that's sticking right out straight in the front of the aircraft. So you don't have a lot of visibility to the left, right, behind them.
Question, so from the aviation side of things, is a pilot, like obviously they have their things that they're tracking, other planes communicating radios and they have visual because they're in the plane. Are they also tracking unmanned systems from the plane?
That is, so
Or is that just too much to while operating a plane?
they are not typically tracking drones, specifically small drones that people like consumer or prosumer level drones. Just because they are very small, they're very difficult to see. Generally, they're at lower altitude than the airplane is, so you got a lot of ground clutter behind it that it blends in with very, very well. So it's not that they are, the FAA says the pilot's responsibility is to see and avoid all of their air traffic. So see and avoid and drones don't really mix very well. See and avoid, this is also why the onus is on a drone operator for them to yield the right of way to all of their aircraft, because they've got the best idea where their airplane's at. And they're the ones that are supposed to be using their ocular sensors that sit in the front of their head to clear the airspace that they're operating in. So when you want to start taking these airplanes, these drones, and mixing them in with airplanes and operating environments where you can't see it anymore, you're going to induce a time delay from when you know that there's an airborne hazard out there to the drone, or that your drone is an airborne hazard to some other aircraft. There's an inherent time delay in how long it takes to recognize that threat, react to that threat, and avoid being a threat to other aircraft. So this is why it's so difficult to get the waivers from the FAA. Right now, there are methods of doing this. One that has recently been approved is an ADS-B only target. But if you look at this, here's the difficulty with getting ADS-B information. If I zoom in here, you're going to see a lot of these airplanes have stopped because they're not being tracked anymore because they're already on the ground. The other thing is that these feeds are usually between 15 to 30 seconds delayed. If you're looking at this is an airplane that's in the pattern and it's doing 110 knots. 120 knots means that you are covering 2 miles of ground in 1 minute. So we're talking about fairly increased speeds when you're talking about airplanes versus what cars or general ground vehicle traffic is doing. So ADS-B in and of itself is usually, most of the public sources to be able to get the ADS-B information is delayed. So you're going to have to use a lot of interpolation to figure out where those aircraft are at. And not all aircraft are transmitting their positions via ADS-B. You can have equipment failures of specific things where the ADS-B isn't working anymore, which means you could be putting an aircraft in danger from a drone if the drone is relying solely on this information.
So I'm thinking Alaska and ADS-B, right, with the general aviation people.
Yep.
And they brought that, so that's diminished incidents, but it's still an issue of speed and time
Yes.
of that.
So whenever a waiver is written, so another mitigation to do is to do a radar-based solution, which is where DTEX has helped other companies with their safety case in order to be able to fly beyond visual line of sight. So this is kind of a generic display, and this is a live display of the radar that we've got out at Gorman Field right now. So it's just south of Grand Forks Air Force Base at that small UAS airport I kind of mentioned earlier. So we've got two rather large airports in the vicinity, one that has a lot of traffic going through it. So at the moment, this display is going to show you if an aircraft tracks inbound. And since it's a live display, I haven't recorded it. Going to get, this is a three nautical mile circle out from where the center of the building is, or where the radar is at the moment. We can also modify this so that these circles will follow the aircraft around the area. We have this set right now to about 6 nautical miles range, which is it's about right here, just north of where Highway 2 is depicted on the map, and just about where this I don't know how well anybody can see this, but there's a highway down here. This corner is about 6 miles away.
So that radius would stay with the aircraft?
That radius will stay, this radius will stay with the aircraft. We're within the range of our radar. So where we can detect aircraft out to 3 miles away. So as you can see, we just popped one up. This has ADSB information, but it isn't yet verified by the radar. So we're getting the speed and the altitude of that aircraft from the ADSB information that it is transmitting. The way this system works, if it is a small triangular target like this, that means it's ADSB only. If it's a red target, it means it's radar only target. And once the radar picks this up for a significant number of scans, it'll turn it into a radar verified target, at which point the speed will be reported by the radar. And the green triangle will turn into a larger target.
What's the tail? How is that length based?
So right now the tail is 30 seconds of history. We are planning for this specific installation. We're planning on going to a 90 seconds, so a minute and a half long tail on that to make sure that somebody has an idea of where the airplanes are at. Also, one of the improvements we're going to do to this is we're going to open up the range on the ADSB so that it does cover out to about 30 nautical miles instead of just the 6 nautical miles with the range of the radar.
So I take it it's a 2D radar?
Yes, this is a 2D radar, and that traditionally is what we've gotten approved for beyond visual line of sight safety cases. At which point with the operational side of it, you would write the waiver so that if you had the ADSB information, like right now, this one's at 7,600 feet. You're not going to be a hazard to that if you're down at 400 feet above the ground. So with the altitude information, you can avoid that air traffic by staying not only away from it in 2 dimensions, in a latitude, longitude, but also with an altitude separation. If it is a radar only track, you're going to want to make it a cylinder. So you're going to have to do, if you've got a 2D signature, you're going to need to do 2D avoidance of that other aircraft.
So do you see this turning into like a type of 3D type of perspective?
So we do make 3D radars.
Like this interface, I'm saying?
Yes, well, they'll interface the same as this if we need them to. So we're currently developing those. We have the radars. They are in operation for some other. Right now, we're using it primarily to track birds in different locations. The update rate is faster. The update rate on the 2D radar is about 2.5 to 3 seconds is when that position is updated. The 3D radar is looking in all directions at all times, and the update rate on that is less than 1 second.
So your radar, is it omnidirectional? How's it actually scanning?
So this one, okay, so we just got a perimeter violation. So that's within 3 nautical miles, the radar will tell us, will start flashing like that, give you a visual alarm. If the aircraft was heading towards the center of this or the aircraft, depending on whatever this is following, at the 2 nautical mile ring, this will flash yellow, and you'll get an audible alarm.
On the intercom?
On the next one in, yeah. And then within half a nautical mile, this will turn red and continue to give you the audible alarm. And at that point, usually all 3 of these are flashing. So it will definitely tell you that you need to do something.
Will that take the projected flight path and base warnings on that, or is it just where it is right now? You know, like for it.
It depends on the application. It depends on the customer.
Okay. You modify that based on stuff.
The technology exists and can be available, but it's also ITAR controlled on some of those things. So if you look here, this aircraft is at a pretty significant altitude, and we have about a 15-degree beam height on our 15 degrees in elevation, and azimuth we're at about 2 or 3 degrees. Actually, it's tighter than that. Anyway, because this is at such a high altitude, a lot of this particular flight has been above where our radar can see it. So he's flying above the radar. We can see all the way down to the ground, since this is primarily going to support beyond visual line of sight operations, we do have it, so that we can't see to the ground. Anyway, sorry to cut you off. So, a lot of times people will ask what a typical day looks like. So this is what a typical day looks like to the radar.
All right.
So this is the 29th of, August. A good flying day. So I think each one of these lines is a radar track that our radar database has in it. And being difficult to control with the camera being where it's at, and me standing between. So for one day around Grand Forks,
This is from Gorman Field.
this is from the Gorman Field radar, and it's got 18,500 tracks that it picked up in that 24-hour period.
So if you have one that gets too close or anything like that, is it highlighted automatically and that type of stuff for you?
This is just data for reviewing airspace or finding out what we saw for the track.
You have to put it.
And we kind of do that. So from the same day for the same 24-hour period, that's what the tracks look like. So on these tracks, what you can see, and these are, we've also got, if you look right here, and I can zoom this in if you guys can see it real quick. Just to show you some of the detail that we've got. The colors are going to delineate the colors in this display where we've pulled the daily report in a pictorial format.
That's your pie.
Yep, it's a pie that's up in the top right-hand corner, but since I'm zoomed in, you can't see it. So in general, blue is northbound tracks. Magenta is a eastbound track. Orange is green is west track, and red is a southbound track. So this is where Gorman Field is right here. As you can see, we do pick up tracks to the ground. So there's a paved road that goes past, or it's about a mile away from Gorman Field, and it goes up to Emerado, North Dakota. So that's what this track is vehicle traffic. It's the same with this green track right here. These smaller kind of squiggly lines where it's really undefined what these things are doing, those are birds that have given us a significant radar return to generate a track. And then if you look at the larger ones, these are all going to be airplanes. And this is radar only data. This does not have the ADS-B data infused with it, because it was going to get really confusing and really busy if I did that. There's a visual reporting point that's right in this area right here. It's called Watergate. So airplanes that are doing training flights to the southwest will come in through here. A lot of the reason you see these tracks coming from the southwest and going in, funneling into this point right here is because there's that temporary flight restricted area that's just to the west. These aircraft that you see that have gone through the temporary flight restricted area, those have gotten TFR transitions from air traffic control. So you have to give permission to use that airspace because Grand Forks Air Force Base owns that airspace within the TFR.
So then UND Aerospace has an agreement with the Air Force Base to get in there?
No, absolutely not. They have to give permission just like anybody else does. So that's controlled primarily because of the control system of a global hawk. It's a significant distance of time, or it's a significant time delay for them to try to avoid something. So they're not avoiding anything. So everything else is avoiding global hawks. But you can see, you look right down here, you see almost at the top of a racetrack pattern we picked up on radar. Then you see these blue lines that are going into Grand Forks Air Force Base. Those are practice instrument approaches that students flew that day. You can also see kind of the racetrack pattern around Grand Forks Air Force Base. This would be aircraft that are in the traffic pattern and practicing takeoffs and landings. Most likely those are MQ-9 Reapers. So This is the airspace picture that the FAA looks at when you're asking for beyond visual line of sight flight. And when they are seeing traffic loads like this, that's when they are fairly hesitant to approve you to fly further than you can see a drone before you, without a reliable method of knowing where your aircraft is at all times and where all the other aircraft are at. So Johnny, give me a question.
So how does it know? How does it distinguish between an aircraft, or is it just interpreting the map for the user?
So on this display,
Yeah.
display right here, these are all targets that have generated tracks. So a track will be generated and logged if we get 3 consecutive scans with the radar.
So 9 seconds straight.
9 seconds of operation, we'll see that it's an airplane. If you look in very close to where the radar actually sits, which is right about here, we have put in place a mask over this road because this is a paved road, country road where there's a lot of activity. And we don't want tracks to be generated along that road. So for the couple of miles that this goes through the area, we have that one blocked out. There's less traffic on the north-south highway that's right out here. So that has generated tracks for us. Once you get in really close here, this could be trees that are moving in the wind. And so they've generated tracks. There's a stop sign right here. This might be a stop sign, and just every consecutive sweep, the stop sign is moving enough where the return says that it's moving. So it generates a track report. So this is generally ground clutter when it's within a fairly close area.
Lighter blue, the same paths as the darker blue, or are they like moving faster?
So it's not dependent on speed, it's dependent on direction. So if you look up here, a lighter blue is going more northeast. Green is going more east, southeast, south, southwest, west, northwest, north.
I've seen that little pinwheel.
Yep. And I know that, but I wanted to show some of the detail, which is why I zoomed in. So yeah, when you see these multicolor tracks like this, that aircraft was probably, that was probably doing a holding or a procedure turn. Actually, it was probably holding.
So now, how do you compare to Talus as a tool for what you got going here? Are they similar to what you're doing type of thing, or how does that work?
So I wouldn't say that we wouldn't compare to Talus. We are a tool or a sensor that can be added into a network such as the BANUS network. By making sure that our data will be able to be ingested by Talus's equipment because they're administering the BANUS network. So that's kind of where the BANUS networks and Talus says that the BANUS network is a system of systems. So they are using radars currently out in western North Dakota for the.
Those are the ones that are already approved for aircraft, so.
Well, yes and no. So like everything else, like every answer that I could give you, similar to what Joel Vasic says and aviation, it all depends. We use similar radars to this that are, the sweeps are longer, but the range is greater. And we use those radars for aircraft detection lighting systems around wind turbines. So when we detect airplanes that come within the perimeter of the wind farm, we'll turn the obstruction lighting on so that the airplanes have a last visual reference to say, hey, you're at low altitude, you're flying into a bunch of blenders. Make sure you don't fly towards the red lights.
I have a controversial question.
Okay.
Current to the time, is there any issue at all with tracking everything? Like, do people have a concern that they're in a car and they're tracked on here? I mean, it's no different than you seeing them drive by, obviously.
So
But has you ever heard of that concern of?
where we generally get concerns is going to be in our ADLS systems around wind farms. And it's generally in the form of complaints that the lights are on too much. And it's because enough geese will give us a radar cross section that says that they're an airplane.
So for those of us who don't understand how painful that would be, you're at your farm and it's night and you're literally blasted with like police floodlights, similar to that.
No, but they're pretty constant. They're on, off strobing red lights. And if you're talking about a wind farm that's got 300 turbines in it, that's a fairly big one. But even if it's 150, they're all, if your farm's in the middle of it, you're leasing land for a turbine to the power company. 150 lights is going to be very, very, it's a bit of a, there are some cultural restrictions where you don't want to screw up people's views of northern lights. Say, would be a great example where you really screw that up if you were visiting a national park. So obstruction lighting is one of the, is kind of our meat and potatoes right now. But our,
Is that a law too? Or is that a law
that law is administered by states. So North Dakota was the first state out of 50 that had a statewide law for a light pollution law that said that the lights had to be off if they weren't needed on the wind turbines. So that's why we do have a significant number of, we've got a little over 50 radars in the state of North Dakota.
and would they all have their own similar kind of platform like you just showed us?
Yep.
Just customized maybe to what they care about?
Yes. So, well, yes. They are custom built and there's a package that's submitted to the FAA that includes view sheds or diagrams of what our modeling software says that we'll be able to see, what ranges, what directions. Sometimes if you do have an obstruction that's close to an airport or is impinging on their airspace, we will have limitations where one turbine has to be lit for the due to the FAA's desire to make sure that that turbine stays lit all the time, either because there's a hill in the way and we can't see that turbine, or because it's close enough to an airport or a heavy operations aircraft.
So obviously with like the future of beyond visual line of sight, people kind of racing to figure out who's gonna take care of it. Maybe there'll be multiple groups, probably a bunch of subcontractors. You have a ton of tools that basically can make it safer, you're maybe have 5 different things that your radar does that someone else maybe doesn't do. And then I would assume that maybe with the beyond visual line of sight access, it would see all of your radars into one, or would that be more like,
That's a consideration that we're moving towards. It's a, I don't know how to say this, but yes, that's a thought that we've had that we've started exploring, is to combine multiple radars. Thing is, when we sell radars, we sell the radars. And so whoever buys the radar, they own that radar, they own the data it's producing. So there are layers of how do we talk to them to see if they're willing to give that data to somebody else. Especially if it's an energy company that's been forced by a law to have $1 million light switch for a bunch of lights. They're already unhappy they have to begin with. Why would they give it away for free?
yeah, so that might be some type of thing where they get a maybe cut of the overall picture, but you also have cameras that are tracking the same stuff, correct?
The cameras don't specifically track. We have that ability where the cameras could track. In general, we also make RF sensors, and we're partnering with a company for remote ID so that we can see where the drones are at. Either if they are compliant and they're broadcasting their position with remote ID, or if they're not compliant, but they still have a command and control link, we can pick that up. So we can use any of those sensors or the radar and ADS-B receiver to steer a camera to point it at a target and start getting a visual, getting a look at what that target is that we're picking. Is there?
How for your single radar that you have out there, what is the maximum range for that?
We are still determining that. This is one of our newer, smaller form factor radars. We were expecting and designed it to be about 3.5 miles. We are consistently and reliably getting we're getting the range of an intended target on aviation single engine airplane. We are getting that to a little better than 6 miles. So
Yeah, just looking at if you're a business, maybe you buy one of yours and put it on a truck, apply for a waiver.
We do have- We do have mobile platforms, to include the one that's on the truck that UND has that they use for, their situational awareness for scanning of flights. That is also a detect radar. It's a few generations old, but it still puts out the same data, it uses the same science. So, yes, sir.
How does this help you with a BVLOS waiver?
So with the BVLOS waiver, where we can go is because the radar is an active sensor. So because it's sending a signal out and looking for things, it's not dependent on the aircraft that are out there to tell us where it's at. ADSB does that, where the aircraft is broadcasting its position to everyone all the time. One second. Hey, Gray, how's it going? The way that a radar is used to be a safety case, BVLOS safety case, is that with this, because we're an active sensor, we're going to see the aircraft that are and the aircraft that are not required to be broadcasting their position. So for instance, crop dusters, agricultural operations, a lot of times they will not have an ADSB on board. So they are not telling everyone where they're at. But with the radar, we can see them at whatever distance. If there's an airplane that has an ADSB system, and we've seen this, we've actually got tracks where it appears that there's an ADSB target that is just moving across the ground at 0 altitude and 180 knots of airspeed. We're going to see that and have with our 3D radars, we can tell what the altitude is of that aircraft and what the actual airspeed is. One of the problems with the ADSB information is it is not a secure message format. It can be easily spoofed or duplicated. There's a lot of things you can do to kind of overwhelm the air traffic control system if you're only operating according to an ADSB platform.
Are you talking just like, I developed it before, but it was like $100 little ADSB sensor. Is that the same data that you're talking about, or is that for a drone would it pass the same information? It's like a little microcontroller
And
that,
that's just a receiver that you built?
well, I bought it, it's like a dev kit, then
Okay, so that's a receiver. So yes, you
a year and a half ago,
you
right?
can very easily buy the components and find the instructions to get an ADSB receiver and have it, a little Raspberry Pi thing.
It was for one of the gas powered drones, but I imagine that's the same, then that's the same signal it's spitting out to,
The airplanes are spitting out their signal to anybody who's listening. Yes.
So was that just a receiver or a transceiver?
that was both, but I'm wondering, so why would you not want to have it? Wouldn't it be in your best interest to be safe, or is it a privacy thing?
Okay, I'm not 100% sure what you're talking
Like
about.
on a plane, why would you choose to not, like a crop duster, why wouldn't they have one?
They've got some exceptions where they don't have to add the equipment. For an aviation certified transmitter, it's going to be a far higher, it's going to be more expensive. You
Oh,
can't
okay.
build one.
Okay.
You're gonna have to buy one.
So if it was free, they'd want one.
Right.
Okay.
And so what we use is the ADSB receiver that can handle both frequencies of ADSB that are accepted in the United States. Most other places in the world are not, are a single frequency that they use for ADSB. In the United States, it's 2 frequencies. That was to be kind of an early adopter of the technology and to make sure that the bar to entry for an airplane owner was as low as possible.
So ours was a receiver so that the drone signals could be in the UTM platform.
If yours was a receiver, you were using that to find out the position of the other airplanes. And for instance, when I was saying the public source is usually somewhat delayed. So if you're looking at FlightAware or some of the other services that you can just log into, ADSB Exchange, a lot of times they will delay their output for, sometimes they'll delay their output. If you are Elon Musk, you may not want everybody knowing where your airplane's at. So you can pay that service to not broadcast where your airplane is at. Although it is still broadcasting its signal to every other airplane that's out there and air traffic control.
That's just a paid service, but anyone else could receive that data and do what they want.
There are ways to do that.
So what's your height at 3 miles and 6 miles? If we can go to the ground, how high at 3 miles and then how high at 6?
So we've done, we've actually done those. So the height is, it's got a cone of silence similar to any other radiator or radio signal that's going to go out in a wedge shape. So as you go higher in altitude, the cone of silence over the center is larger. If we're talking about a standard size general aviation aircraft, so a single engine airplane with that type of radar cross section, I believe we're at 900 feet above ground. We're about a half a mile away is where we can't see. So if you look on the picture that we've got right here, we do have some aircraft, and these are generally single engine general aviation style aircraft. But you can see where we'll lose the track where they're going directly over the radar. And so these are probably 6,000 feet coming out of Grand Forks. We'll lose the track here and we pick them back up over here. But when we have this information coupled with the ADS-B, we will still see the tracks. The ADS-B tracks will continue through that.
So that's because of the actual radar in the cone of when you're right over it.
Yes, because our radar is our wedge that goes up and down is much larger than our left and right, so that we have a very strict definition on the X and Y for the latitude and longitude, but we don't have the altitude information from our 2D radars.
So do some of these have too close to each other, facing at each other, or no?
So that's one of the things that we're very proud of at DTECT, is that we can put radars very close to each other and not interact with each other because of the way that we structure the frequency gap between the radars where they're operating within the band of frequencies that they are operating in. So we have very fine control of how many channels within either the S band, primarily the S or the X band of radio wavelengths.
And the azimuth is mechanically scanned, literally rotates.
Yes, on our 2D radars, that is the case. On our 3D radars, we have an electrically steered ray.
On these, but that's where the latency comes from.
Yes, so the latency on the 2D radar is that we update that position once per revolution.
That's right.
On the radar.
It
So
takes
that's why
like 3 seconds to go around.
takes I think it's 2.8-ish. It depends on what RPM we're spinning it at. We can get much better resolution with a slower RPM rate, but we don't get then we have a slower update rate.
What's the uptime on the radar data?
You mean the update?
Like, do they go down? Does the internet go down with it? Is there issues ever with this? Just one of them in the data flow going down, or?
So they are specifically, if we're using them in the realm of the FAA, of aviation safety, the radar itself, unless something's really bad happens, like it could get hit by lightning, hailstorms, something that's physically damaging the radar. We have the UPS or uninterruptible power sources, so we've got battery backup. We've also got generators that will kick in for standby power. At Gorman Field, the Mark V that we've got there is on a uninterruptible power source, and then that entire building for all the flight critical components has a backup generator that will kick in and pick up the load. So with an obstruction lighting system like our aircraft detection lighting systems, it's more of a dead man switch than it is. We don't turn the lights on, we keep them off. So if any part of the system fails, even if it's an individual turbine that's not talking to the light controller anymore, the lights will fail to on.
Got it.
So if that part of the system goes down, the lights would go to on. If we're in a beyond visual line of sight safety case,
Like to go to on if it fails,
yes.
so that it's never a safety issue.
so that it's as little of a safety issue as it could be. There are probably some factors outside of our control where you could get the lights to fail off, but it would have to be a catastrophic failure of the entire system. So far, if our radar feed goes down for any reason, then those lights are going to be on all night. If we're talking beyond visual line of sight, drone operations, if the radar goes down, then in the operational procedures, the aircraft are either going to return immediately or they're going to land immediately, and you're not going to be able to take off without the BVLOS safety.
But one thing I've thought of after seeing your system, which is very interesting because everything can get hacked.
Right.
And when you're on the internet, it's hackable. The safest thing now is like, my mom's password book from Hallmark in the 90s. It doesn't touch the internet.
Right.
Who knew that's the safest thing there is. Your system can actually be deployed on site using local hosts where technically you wouldn't need the internet. You could still consume the data from your radar, consume this, and it wouldn't actually touch the World Wide Web.
Yes.
Because it's all local, your web app and everything would consume your radar data locally, and then you could technically you just have it within miles for, with your own network that never hits the actual internet.
Correct. So
But you can monitor your own stuff.
Yep.
I think that's fascinating for farmers because they like that privacy.
Yeah, and then you could do you could have a you could have a firewalled or access controlled point where you could allow people to see your data that were paying for a subscription service, those kind of things.
Well, I think it'd be interesting if it was off all the time to the general world, like a farmer or like an XL wind or something. And then there's an on switch when someone needs that data coming by, but the default is private, local. They could even have it local to 4 or 5 miles, know what's going on, and no one else can even get to that system.
Right. And all of that data is owned by our customers or who we've sold the radar system to. So however they choose to structure whatever access controls they choose, except for, proprietary data that some of the things that the secret sauce that DTECT has is not necessarily in the radar itself. It's not the technology. It's the processing of the data.
Sure.
That's where the cool stuff happens. So, we've got controls on those type of things as well. But
Are you able to show that the demo where the camera was moving towards and recognizing what was up flying by, just from more lay terms of what does this equate to?
might take me a minute to find it, but
I think that's for less aviation folks. I think that's pretty fascinating okay, this can identify maybe this is a bus on fire. This is a bird. This is a drone. This is a plane.
That's optical.
A camera would
so it's a
engaging
combination.
with the radar.
Yeah, the ideal setup and the way to get beyond visual line of sight is a mixture of sensors. So different sensors. Johnny, I think you were talking about these.
Yeah.
I don't have these set up in a loop, but you can get an idea of the way the systems work. So this is an interactive system. When you point at any individual target here that's being tracked, it'll swing the camera to that point with the correct altitude. These are all turkey vultures that are flying around an Air Force base that historically has a lot of bird issues. They're also a training base, so they need to know where those airplanes are at versus where the non-compliant bird traffic is.
Yeah. I just like the confirmation with the video because, someone could be staring at that all day long and say, no, this is actually something specific coming this direction,
Research with that tool with environmentally birds. So one of the things I saw before I came up here to go to school was they were finding sharks in the water visually.
So
I
now
think
this
that's
is
really cool.
this is what Johnny was kind of talking about this, where it's a bit choppy. We have refined this, but I do like the fact that you can tell that every time the radar sweeps, every couple of seconds, it's updating the position of that camera to make sure that it's pointing at the drone that it's sensing. So on our user interface for this type of application, safety or aircraft safety, we're delineating the difference between a drone and a bird, as well as we will have different icons for targets that are moving around on the ground and airplanes that are squawking and talking and tell us that they're airplanes.
Yeah, it must be valuable if like something happened down the road with that aircraft, seeing that there was footage of maybe it like had some problem and it was coming by, or you could tell from the video that it wasn't flying correctly. And then down the road, it broke some rule or crashed or, you had a visual on it for a little while.
Yes, and it's still, I remember doing the legal classes and the frames between what happened in the frames between the video, each picture that makes up the video. All of those are difficult legally, so
Or just knowing like what it was.
yes.
If it blew up and it's like, this was a drone or was it something else?
Right, and we do have, in the counter drone or counter UAS space, we do have sensors that will do that, that will find where drones are at, versus where airplanes are at, and be able to identify that it is a drone. We do not do any engagement, so we do not, we don't do any of the engagement things, but there are arenas within that industry where we can give our information to an authorized party that can do engagement.
So you detect it with your radar, the swarm or whatever it is, you get an optical on it. And it'll-
If you went back to my Army radar terminology, we'll hook it, track it, but it's up to somebody else to.
Really?
Hey,
Yes. Been talking to you and to a university too much to where I don't want to use any aggressive.
Yeah, they might offend them.
The systems are trying to.
this is an EO camera, right? So, bad weather night, you gotta have
This isn't a little.
millimeter wave radar or some other ways of confirming that.
Yes. If it was in the military, there is a kill chain that you have to verify that your target is what you think it is. It's friendly, unfriendly. And you've gotta, when you get to that point, you gotta know what's underneath of that thing. Because
No, I'm not talking about counter. I'm just talking about flying beyond visual. If you're doing sensor fusion, EO camera is probably not sufficient.
There are companies that are using EO cameras. Typically, they're fairly short range, so they're 1 to 2 kilometers. So you're talking about maybe a mile of about a mile of visibility. And so the solution that I've seen proposed by strictly camera companies is that they will have 360-degree staring cameras, but they'll put a network of them out. So they'll kind of put a lot of them down and plant them like corn so that they all overlap.
Oh, no, that's not what I'm so worried about is, let's say it's raining, or it's nighttime. right?
Raining, nighttime.
These are all passive cameras.
Correct. I mean, ours is, so yeah, well, cameras are passive because they're using whatever light source they have. If they're electro-optical or if they are infrared or, outside of the normal visual range. But at that point, the camera technology that's available is generally pretty light on the resolution. So it's much more difficult to find something in infrared, for instance.
Approach the drones in the air.
Sorry. A little bit louder.
Do birds ever approach drones in air, like to take them down?
Absolutely. All the time. You can see videos on YouTube of people who have their drones that specifically like raptors seem to like to attack drones.
Randy Johnson could throw it, hit the ball and the drone at the same time, or hit the bird.
Yeah,
Drone a whole lot easier.
that was great.
Birds are generally more maneuverable. And they're controlling their maneuverability on board, where a drone is not.
How big of a drone could a bird take down? I'm just saying like what you've heard of like,
Like, how big a boy are you?
no, I'm saying like if a global hawk hits a bird, it's flying, right?
bus stop, we'll figure it out.
It's
So-
really,
Really? It depends on the size of the
No.
bird, the mass.
I've had small birds and Learjets,
Yeah.
put huge dents into leading it.
Um,
Depends on where it hits it, how it hits it.
We've had, UND has had, in the past, you hit a goose with a Cessna 172 or a Piper Archer, it is going to cause some serious damage there. So it's all a mass, mass velocity. It's just a formula of what,
Something they could hit to like honk to scare away the bird or whatever.
you mean like deer whistles that you put on the front bumper of your car?
I was thinking more like a car horn.
You'd have to be able to, so once again, there's the time that it takes you to recognize that there's a threat, process that is going to be a threat, that it's close enough that it's going to hit your aircraft, and then do something to take some action. That's usually about a 2-second process. When you're flying an airplane at 120 knots or, you're covering 2 nautical miles. In the time it takes you to recognize that there's a bird that could be a problem,
Late.
you've kind of already hit it. When I was doing my commercial check ride, I did have to avoid 2 flocks of birds. There was one that was fairly high, one that's fairly low, and we basically just shot the gap between them, hoping that none of the geese decided they were going to change which flock they were hanging out with until we got out of there. So, birds. So you brought up a good point. Birds can be a hazard to drones, specifically as we move to larger drones, where it's a more expensive aircraft. There are more important things that are on board, up to and including advanced air mobility, where we're talking about an air taxi. And now you're going to have to start worrying about the same hazards that traditional aviation has been worried about as well. So those are things that people are starting to take a look at on how do you mitigate those types of things. Luckily at DTEX, we've got multiple verticals, so we do look for small targets. Kind of got our start looking for birds and trying to help manage birds, as well as detecting and classifying where birds are going, what they're doing, and what they are for environmental sciences, aviation, mining industries, all kinds of stuff. And even detecting small pieces of space shuttle that were falling off the orbiter during launch that you couldn't see through the smoke to see. That's kind of where DTEC got its start just over 20 years ago. It's working with NASA. Any other questions?
Yeah, so what's the answer?
What's the answer?
How much? Just kidding, but if there was some project that obviously this technology, all these types of technology are expensive,
Yes.
are there other opportunities for radars to be implemented somewhere where
So
it does something good and the people can partner with you guys, or?
Yes. We're looking at different types of models to help kind of ease the financial blow of how much radars are, because it is expensive technology, and it's you've kind of got to, when you're talking to people, especially in the aviation space, you've got almost exclusively 2 different camps. One who says, how much is your least expensive radar? You say $250,000, and their eyebrows shoot from the front of their head, kind of back here, to where I got the hot dogs. And those are the ones that are like, oh my God, that's ridiculously expensive. And then you've got other players that are maybe DoD contractors or something like that. Like, oh, well, that's cheap. Might be because they know what DoD radars cost. So with that in mind, when we are working with some customers, we do have lease options where we'll do a lease to own, so that customer can spread that amount over time. We can also do radar as a service, so kind of a rental. Around North Dakota, that may make more sense, because typically here, the drones aren't being flown when it's 30 degrees below zero. So that may be an attractive option to certain companies that are doing agricultural work when they're looking for ground emergence, or weeds, or doing hydration surveys with near infrared sensors, red edge stuff. So we try to make it an approachable solution for the majority of the operators that we can.
Have you heard at all about what people are doing for the inline infrastructure waiver? How they are able to do the BVLOS with the power line and kind of the duck and hide type of thing, but how are they maintaining awareness? You can't see it anymore.
So with a lot of linear infrastructure projects, power lines, pipelines, that type of thing. Those are what DFA's has kind of deemed shielded operations. So at that point, you're not going to expect an airplane to be flying within 50 feet of that power line. That would be extraordinarily dangerous. Similar to what operations over people used to be. And if you are going to fly, if you're going to deliver a taco, Johnny, to somebody who's golfing, you could primarily stay over the water hazards or the treed areas. You don't expect people to be underneath that. So that's the concept that the FAA uses for shielded operations, which are where you're within 50 feet of a building or a linear infrastructure. That's a safer environment for the drone to be operated because you don't expect larger, faster, less maneuverable aircraft to be in that close proximity to that structure.
Well, then just let it be up to your risk if you want to fly it through the aircraft.
You still can, you can still do, you can do those operations. A lot of times you'll still have to sometimes you'll still have to get a waiver, but if you can make sure that your aircraft is going to stay within that shielded or protected area, then you're good to go. Similarly, if you are flying in LANCE authorized area, so a low altitude automatic notification, can't remember what the C is, but so the areas around airports that have the grids where you've got the different altitudes that you, yeah. So you can get automatic approval for those. And basically what happens is that information gets transferred to the air traffic control facility that's controlling that airport, which may be the FAA. And then generally an automatic notification will be published so that if you are a traditional pilot of traditional aircraft, the information is there that there's going to be something happening in that sector or in that airspace with letting you know what altitude below that aircraft will be there. Similar to the NOTAMs that have an obstruction that is unlit. So there's a tower that the light bulb burnt out. So that will be NOTAMs for that airport for that until that light gets fixed. So there are different layers of protection, but everything does depend on somebody actually going out and looking at it before they go do things. So.
You had one of your products out at the Air Force Base, right?
At different times, UND has had their radar truck that has a detect radar on it out there.
UND.
So if UND was out there, then I guess one of our products was out there. But I did make sure that we talked and we're cooperating with the approach control radar at Grand Forks Air Force Base when DTEC put our smaller radar within 6 miles of Grand Forks Air Force Base to make sure that we were, and what we did is we let them know what frequencies we were planning on using. They sent back and said, yeah, that looks fine to us. So we made sure that we wouldn't interact with the approach control radar that's out there.
So at this point, the only onboard tool is ADSB transceiver.
So not a transceiver because in general, drones are prohibited from using ADSB out. They can use ADSB in, but they cannot use ADSB out. If you're
Well, how do they then transmit? Oh, so that's only a manned aircraft that's sending ADSB out.
yes,
I didn't know that.
drones at this point, the FAA's laws have gone into effect where you have to have remote ID. So remote ID is the drone is broadcasting this similar information to what ADSB does for traditional aircraft. The drones are using remote ID to transmit their location.
And that's at a different frequency than ADSB, then I take it?
Yeah, typically that's either Bluetooth or Wi-Fi.
Okay.
Are the frequencies that they're using for remote ID. It's supposed to be a fairly short range where ADS-B, you can pick that up for 100 miles. Remote ID is designed to be
So-
a license plate.
But back to the original question. So there's really nothing on board UAS that's going to,
Got something that transmits?
UAVionics does make a remote ID module for drones that were made before the remote, the RID module had to be incorporated into the drone. UAVionics, and there are some other companies that make RID modules to retrofit drones or model airplanes. But that's just broadcasting their position. So that's not sensing where other aircraft are at. There are some companies that have developed, for instance, camera systems that are looking for pixel mapping or using pixel mapping to look for other airplanes that are in the area that could be a collision hazard so that they can feed to the onboard autopilot where that threat is at and that collision hazard. To this point, most of the information that I've seen about those is that they're not terribly practical because they take up most of the cargo carrying capacity of the drone that they're installed on. Specifically, if you need a 360-degree view, it's not a fixed wing drone. You're gonna have to look all the way around the aircraft at all times. I've heard good and bad about how the approval process is with the FAA, whether or not you can get that type of system approved. So there's no magic bullet. There's no one ring to rule them all. The one ring is a combination of RF camera or optical sensors and active sensors like a radar that's looking for things that are out there. That answer your question?
no, I want to know what's being written into Part 108 in terms of onboard sensors necessary.
So there are
So
some.
not sensors. I'm actually talking about active sense and avoid capability.
So at that point, you're looking at, the FAA has been evaluating ACAS, so automated collision avoidance systems. So with Part 108, so Part 108 is what everybody's referring to as what the advanced operations set of regulations is going to be from the. For Part 108, which is kind of the BVLOS stuff, you're generally not talking about consumer level drones, so that's how you're going to get beyond visual line of sight. So you're talking about, a decent amount of expense, decent amount of system complexity, redundancy, and reliability. So those aircraft, if you're going to do Part 108 and you're using an onboard system, ACAS is a solution. So right now there are 3 flavors of ACAS. There's ACAS XU, ACAS XA, and ACAS XR. So ACAS XU is for unmanned aircraft. ACAS XR is rotorcraft. ACAS XA is going to be airplanes. So this is kind of the system that's envisioned to replace TCAS or tactical collision avoidance system. ACAS is going to operate in 3 dimensions where TCAS has always been a 2-dimensional, either altitude or left, right, or up, down. ACAS is going to be more of a combination of everything along with the time. And that's where the airplanes can violate each other's bubbles and the airplanes start talking to each other. The TCAS systems start talking to each other and they tell one airplane to climb, the other one to descend. And I'm sorry, TCAS is just altitude. It's really split. ACAS is going to be where they can also avoid by turning away from each other. So that's an added layer of complexity, but there is a system under development that can do that where the airplanes are actually talking to themselves and instructing the pilots on what maneuvers to make. For the drone arena, those instructions can be communicated if the pilot doesn't take action in the outer bubble. If it gets to the inner bubble, then those instructions can be transmitted directly to the autopilot, where the autopilot takes over regardless of what the pilot was going to do and make an avoidance maneuver on its own. So, anything else?
Great information.
Yes, wonderful.
So if people watch the video later and they want to get a hold of you, how do they do that?
So detect-inc.com is our website. And my email is Ryan, RYAN.Walsh, WALSH at detect-inc.com. It's a dash, not underscore.
Thanks, Ryan. It's awesome.
Well done.
Perfect. Thank you.
God, who do?
What?
Who do?
I get all that information?
They do.
I did.